Okay, so this is the second part of section 2.2 in geometry, statements, conditionals, and biconditionals. And we're at a point where just want to reiterate or go over some things that we talked about yesterday. We started talking about a statement, and we wrote a statement down. What letter do we normally use for a statement? P and Q. Okay. We can use R, but usually it's P, Q, and R right in there. Those statements then can be negated by simply putting the word not in there. Okay. For example, if I say Kyle is in geometry class, then to negate it, I can say Kyle is not in geometry class. Okay. You don't say Kyle's in English class. Okay. You just put in a not. Okay. And we used a symbol for not. Then we talked about a conjunction, about putting two together. We put Kyle is in geometry class and Dawson is in English class. Okay, that would be a conjunction. Okay, and it was with and. Okay, and then we went to an or, which is a disjunctive. Remember, a conjunction had what symbol?
Upside down V.
An upside down V, and a disjunction is an or, right? This is an and a disjunction is an or. Okay, so it looks like this. A big difference. If I said Kyle and Dawson went downtown, they both went downtown. If I said Kyle or Dawson went downtown, only one of them went down, right? Okay, we don't know which one. So there's a big difference between a conjunction and a disjunction. Then we changed everything to a conditional. And a conditional is an if-then statement. Okay? If Greeley throws something in class, then Greeley has to stay in. That's an if-then. Remember, the if is not part of the hypothesis, and the then is not part of the conclusion. Okay? It's whatever comes after that. And then we learned how to write it into an if-then statement. Like if I just said, whales are mammals. Then we would say if an animal is a whale, then it is a mammal, right? And we talked about that and how you had to write it the same way. And then we looked at a counterexample of a conditional. If you find one example that doesn't work, that's a counterexample, correct? And then the weird one is if the hypothesis is false, do you even need to read the conclusion? No. If the hypothesis is false, you'd think the whole thing was false, right? But it's not. It's what?
True.
It's true. Okay, so that is weird, isn't it? Okay, so we were at a point where we were talking about a conditional, and we were talking about the inverse, the converse, and the contrapositive. And I gave you a conditional yesterday. What was it? What was the last one I gave you the conditional?
Inverse.
No, yeah, but what was the original conditional?
Rectangle, then it does not have four right angles.
Say that again.
If a quadrilateral is not a rectangle, then it does not have four right angles.
If a quadrilateral is a rectangle, was the original, right? This is the original. Then it has four right angles. Okay, just so you know though, this is called the what?
The hypothesis.
That's called the hypothesis, and this is called the
Conclusion.
So this is P and this is Q, and so we would write this as P implies Q, right? If P, then Q. You got it? All right. Okay, now we're going to write the conditional. And I know you got this down, but I'm going to start from there and then move on, okay? The conditional. And then I'm going to stop with that and add something before we move on. So the conditional is, we switch it around. So a conditional is Q then P. So I switch around. If a quadrilateral has four right angles, then then the quadrilateral, I can say it, never mind, you did above, then it is a rectangle. Do you agree?
Yes.
Okay. Now, the truth value of this is true, correct, Gigi? Is the truth value of this true? Okay, so this, I'm going to give you something new that I did not give you yesterday. If a conditional, if a conditional and its converse are both true.
It's false.
No. We can write it as a biconditional. This is new. This is not something you had yesterday. We can write it as a biconditional. Okay? Let me explain to you what a biconditional is. It's actually written the same. It looks the same, okay? And it has the words if and only if. So Harper, pay attention to this. We start out with the original. A quadrilateral is a rectangle. We get rid of the F. So here's my biconditional. Let me write it out. Biconditional. Here we go. A quadrilateral. Notice we don't start out with if. A quadrilateral is a rectangle. So we start with the original hypothesis. Does everybody see that? And here's the words that you need to write. This is what makes it a biconditional mathematically. If and only if. Notice I use red because those are the words that we add. If and only if it has 4 right angles. Notice there is no if, there is no then in the front or in the front of the hypothesis and in the front of the conclusion. It's a quadrilateral, it's a rectangle if and only if it has 4 right angles. Now, CJ might say, well, what could you write it as? A quadrilateral has 4 right angles if and only if the quadrilateral is a rectangle. Yes, you can turn it around. However, when we correct it, I always have students that get confused about that. So I say to you, please put the original conditional first, the hypothesis of the original condition first, and do it that way so we all can be on the same page. Okay? It's just for correcting purposes. Do you understand that? This is new. So we talked about a conditional and then now a biconditional. All right. So let's talk about an inverse. And you had this one yesterday too, right?
Yeah.
An inverse is not P, not Q, right?
Yep.
I forgot my arrow. Not P, not Q. Not P, not Q. So you look at the original conditional. Now be careful, because it's really easy to look at one of the other ones and write it wrong. So we look at the original conditional, which is right here. Right? Oh, this is what's throwing me. What should this say? This shouldn't be conditional. What should it say? It should be converse. Sorry, nobody corrected that. I'm sorry, that should be converse. Okay, so I look at the original and I negate it. Okay, so not P would be if a quadrilateral is not a rectangle, then it does not have 4 right angles. Okay. And on this particular one, the truth value of all of them have been true so far, right? And now the hardest one. The contrapositive.
Shouldn't we have 4 right angles?
Does not have. It's not P, not Q.
Yeah, it has.
Okay. Now the converse flips them, P and Q, and flips and makes them negated. Okay? Stay with me there, Harp. So it says not Q, then not P. So it takes the conclusion, says not, and then the hypothesis, then not. Yes.
So you flip them and then you do the not.
Yes, you flip them and do the not. So it looks like this. If a quadrilateral,
It's inverse flipped over.
if a quadrilateral does not have 4 right angles, then it is not a rectangle. All right? Okay. I'm going to tell you something you need to know. All of this you need to know, but I want to stress this a little bit. The original, I am struggling with spelling today. The original conditional and its contrapositive have the same truth value. And you can sit here and argue this all you want, because you read the contrapositive and say, that's not true, and it is. The original condition, so this guy and this guy always have the same truth value. In other words, if this is true, this is true. If this is false, this is false. You understand that? So that means that the converse and the inverse have the same truth value. In other words, if this is true, if the converse is true, then the inverse is true. If the converse is false, the inverse is false. Okay, now on this one, they're all true. And that happens. You know? That happens. But there are ones in which that does not happen. Okay? Let me see if I can come up with one.
The banana is blue and the apple is a vegetable.
Well, now that's true because the banana is not blue. So the rest of it is true. The hypothesis is false, so the whole thing is true. What I'm trying to do is get you one that in which the original is true, but its converse is false. Let me think this over for you. Okay? Okay, here's one.
Zoning center.
If you live in Callaway, then you live in Nebraska. Is that true?
Yeah.
Okay. But now do the converse.
If you live in
If you-
Nebraska, you live in California.
If you live in Nebraska, then you live in Callaway. That's not necessarily true.
That means the inverse is false.
That means the inverse is false. And the contrapositive, let's take a look at the
If you don't live in
contrapositive.
It's true.
Nebraska.
If you don't live in Nebraska, then you don't live in Callaway.
It's true.
That's true. It's the same truth value as the original.
Aren't there other towns?
Yes, but we're just saying Callaway is the only Callaway. This Callaway is what we're talking
In
about.
Nebraska.
Yes, yes. This Callaway is the one we're talking about.
There's Callaway, Oklahoma.
There is a Callaway, Oklahoma? I don't
I think there's one.
I don't know if there is
Yeah, Florida.
if there is another Callaway in the United States, but you know what I'm talking about.
Callaway Golf Clubs.
Okay, there is Callaway Golf. Okay, do we get this?
Yes.
Okay, all right. So, taking a look at your exercises, okay? I'm on page 126, and we are doing the evens, correct?
Yeah.
And I'm looking at 58 through 78. No, I'm looking at 48, 46, 48, and 50 are the ones you have to do, right?
Yes.
So I'm talking to Harper, and this is where he came up with this. I wondered where he came up with this. But he said if a banana is blue, then an apple is a vegetable. What is the truth value of this?
That is true.
It's true. And why is it true?
Because hypothesis.
Because a hypothesis is false. That's a weird one. That's the word. I know it's weird, but I wanted to point that out to you. Let's take a look at 48. If a dog is an amphibian, then the season is summer. Once again, is a dog an amphibian?
No.
No. Let's take a look at 47. If a number is odd, then it's divisible by 5. Is that true?
Yeah.
Yeah. it
No,
would be.
because,
Is 3 is odd?
um,
Is it divisible by
No.
5?
No.
Okay, so here is false because we can provide a counterexample. So the counterexample is what?
3.
3.
7. 3,
Okay, 3, 5, or 3, 7, 9. Those are all odd numbers. They're not divisible. Does that make sense to you? Okay, let's take a look on page 127, 58 through 78. Let's take a look at 58 through 63. It says, write the converse or inverse and contrapositive of each true conditional statement. So if it's true, you write it, but what happens if it's false?
Find
You-
a counterexample.
You don't write it. You find a counterexample. All right. So let's take a look at 58. A right triangle has an angle that measures 90
It's
degrees.
true.
A right triangle has an angle that measures 90 degrees.
That's true.
That's true. All right, so what's the converse of that, Gigi? I only want Gigi to answer this. What's the converse of if well, first of all, you have to write it as a conditional, right? So what's the conditional? If a triangle is a right triangle, what? Then it has an angle that measures 90 degrees. Now, I have a lot of students that do not write this. They try to do the conditional, the inverse, the contrapositive, all based on this up here. And it gets lost. And I've had a lot of people miss this. So I would suggest you write the conditional first. Now, Gigi, would you give me the converse?
If a triangle has an angle that measures 90 degrees, then it is a right angle.
If a triangle has an angle,
That measures 90,
has an angle, yeah, you got it right. Has an angle that measures 90 degrees, then it is a right triangle. Right? That's the converse. By the way, Kyle, is that true? And we don't have to say this, but yeah, that's true. Do we?
Yeah.
Does it say?
Yeah. If the statement is false, find a counterexample.
No, because
Determine whether
you're
each
pretty much
related
saying it's
conditional
true
is
by
true or
doing
false.
this word.
It says determine it. Dawson.
You determine it and then.
No.
Okay.
and-
So I don't think you have to write the truth value of this.
So we just write.
You just write the conditional. Let me look.
So is the conditional?
Oh wait, you do have to write the truth value. So Kyle said this is true. All right, this is true. So this is the conditional. So we're gonna put conditional. Okay,
So what was the first one we wrote?
that's the
That's the.
this is the converse. This is the conditional right here. I'm getting those two words mixed up.
Now do we have to do inverse?
Now you have to do the inverse. So Harper, what's the inverse of this?
If a triangle does not have a right,
No, use this.
oh, if a triangle
Is
is not a right triangle, then it does not have a right angle that measures 90 degrees.
then it does not
Just have an angle.
does not
Oh,
have.
an angle,
An
not a right
angle.
angle.
Mr. Ellis, I have to go now.
Okay, you got the assignment. You kind of got an idea what's going on. All right. Good luck with the orthodontist. Then it does not have an angle that measures. See a little bit. Measures 90 degrees.
Are you leaving?
No.
I'll actually see you in a little bit.
He's gonna come back for one-eye practice. So I'll see him again.
Is it just in Kearney?
He's going to the orthodontist.
Oh.
I have to pick up my retainer.
Yeah, you're clear.
Okay. If a triangle is not a right triangle, then it does not have an angle that measures 90 degrees. Is this true or false?
True.
Triangle, then it does not. Right. This is true also, isn't it?
So that means they're all true.
Yes. Exactly. That means they're all true. Alright, so then the contrapositive.
It's not P, not Q.
Okay, so if,
Or no, not Q, not P.
if a triangle does not have an angle that measures 90 degrees, then it is not a right triangle. Right?
You have to do 3 of these?
Oh, yeah. Well, 4 actually, because we had to write it as a conditional first, right?
I
And
mean,
the conditional was true, right? So tell me about the contrapositive.
It's true.
Do I need to even read it?
No.
No, because if the original is true, then the contrapositive is true. I don't have to read it. And Harper told us that if the converse is true, then the inverse is true. So we got it all done, right?
Yep.
Okay,
I have a question on one.
Writing.
which one?
44.
44.
So I have if points lie on the same line and they are collinear, but I feel like you could really switch out one.
Actually, it's if points are collinear.
Oh,
If points are collinear, then they lie on the same line.
okay. It has to be like that?
Yes, it should be like that. Okay, what about 64 through 68? It says rewrite each statement as a biconditional, then determine whether the biconditional is true or false. Lines that do not intersect are horizontal. Lines that do not intersect are horizontal. What would be the biconditional of that? Lines do not intersect if and only if they are horizontal.
16.
64, lines do not intersect if and only if they are horizontal. Can I put that here, 64? Or do you want me to wait a minute?
Can we wait just a minute?
Yep.
we did was 58.
What, that one was 58, yes, this is 58. And I would really suggest writing it as a conditional before you start doing the converse, inverse, and contrapositive. It makes it so much easier. Okay, can we go to 64 now, Bo? Harper, you ready?
Yeah.
Okay, so the directions say write as a biconditional first, and I don't always agree with the author. This is one case when I say, hey, maybe you should decide whether it's true or false and then write it as a biconditional. That's not what the author said. It says write it as a biconditional, then decide whether it's true or false. Okay, so it says lines that do not intersect are horizontal. So we begin the same way. Lines that do not intersect lines do not intersect,
Or horizontal.
we don't need that. Lines do not intersect if and only if they, is it horizontal?
Yeah.
They are horizontal. Okay, so now we need to decide whether this is true or not. Let's think about it for a minute. It says lines do not intersect if and only if they're horizontal. Notice we had to take the word that out to make it make sense logically. Lines do not intersect if and only if they're horizontal. Well, horizontal lines look like that, right? Can we come up with lines that are not horizontal that don't intersect?
Yeah, both vertical.
Yeah, you can go vertical lines, you can go like this. As long as they're parallel, they don't intersect. So this is false.
So that's it for 64.
Yeah, that is 64, okay?
Would you just have to say parallel lines, like for the counter?
Actually, all you gotta do is say true or false, CJ, because they do not ask you for a counterexample. They just state whether it's true or false. So I'm saving you some time. So you got a 50-50 shot, okay? All right? Let's take a look at number 70 and 72.
We don't do, yeah.
Okay, write the statement indicated and determine the truth value of each statement. If the statement is false, give a counterexample. So it has it in italicized. Animals with stripes are zeros. Are zebras. Okay. So we would put if
Animals have stripes.
if an animal has stripes, then it is a zebra.
False.
Okay. The conditional would be that's the original. And that's
That-
70, that's false, isn't it? What else has stripes?
A cat.
Cats, tigers,
Birds.
birds, some birds have stripes, okay? So, we would put, on 70, we would say if an animal has stripes, then it is a zebra, and then we would put, we did it, and the truth value would be false. If it's false, give her a counterexample, tiger, okay? Now let's take a look at 74 through 78. It says write the conditional and converse for each statement. So we're just gonna do the conditional and converse. Determine the truth values are conditionals of the converses. And if false, write a counterexample and write a biconditional if possible. Now the author is saying, oh, if it's true, write a biconditional.
Is this 70? No, we're past that.
No, we're at 74.
So what was the last one?
70? You answered it.
So we didn't do 72.
No,
Oh.
no, I'll let you do 72.
Okay.
Alright. So 74, regular quadrilaterals are squares. So we'd say if a figure is a quadrilateral, then it is a square.
That's
Which
false.
is false. So we write a counterexample.
Rectangle.
How about a rectangle?
Yeah.
Alright. So 74, the conditional, if a quadrilateral is regular, then it is a square. Right?
Put
So
false in
converse.
square.
If
What
a
would be converse,
quadrilateral
though?
is regular, then it is, oh, I said it wrong. I read the wrong one. I combined two. I read 74 wrong. Let's do 74 again.
Regular quadrilaterals have squares.
If a quadrilateral is regular,
Then it is a square.
then it is square. And that's a total different statement, isn't it?
Where are we writing more than we do?
This is 74. Says if a quadrilateral is regular, then it is square. By the way, what does regular mean? Normal.
Where?
All sides
No.
the same?
All sides are the same and all angles are the same. So if a quadrilateral is regular, then it is a square. Is that true or false?
True.
That's true. Alright? Then it says write the conditional. So Jaws, what's the conditional of this? Or not the conditional, the converse. What's the converse of this?
If a quadrilateral.
No,
This is the converse of right.
biconditional. We need to do a biconditional.
Hold on. Guys, stay with me.
And converse for each.
Stop. It says write the original, write the converse, make sure you do the truth value, and if they're both true, do a biconditional. If they're not, then we give a counterexample. Alright? Yes.
It's the one that we just
Sorry.
wrote. Is it a conditional or the converse?
This is the original. This
That's
is the
fine.
conditional.
Okay.
Okay?
instead of converse.
What we're doing now is the converse.
Okay, so if a quadrilateral is not regular,
Oh no.
if a quadrilateral
You take if P,
Is-
if Q, then P.
is a square, then it is regular.
Yes.
I didn't.
That is correct. Now, is that true?
Yeah.
This is also true. Now, since they're both true, we can write it as a biconditional. Yes.
Okay, what does it mean by write a counter?
Okay, so like if this wasn't true, like the first one I said, which I combined the two, if it wasn't true, then he said a rectangle. I said if a figure is a quadrilateral, then it is a square. If that I read it wrong, so that would be a rectangle would be a counterexample. And you can still write the conditional and it's false also, okay?
So do you just write one word for that, or like the
Yes.
counterexample?
Whatever,
Okay.
yeah, well, yeah, sometimes it takes more than one word, but in this case it took one word.
Alright,
Okay, so now we have to write a biconditional. So we'll begin with this. A quadrilateral is regular if and only if it is a square. Okay? True. All right, let's look at 78 real quick and then we'll be done. Well, you'll have to finish the assignment, but we'll be close enough where I think you have enough. 78, vehicles. Different vehicles are characterized by different structural features. Write each statement in if-then form. A convertible describes any vehicle with a fully retractable top.
Convertible.
You know what, let's just go to 76.
Yeah, let's do it.
Yeah, let's just stop at 76. So, let's go 76 even. Would you tell Uton
And
Carly.
and Carly? Carly's gonna have it on here, but just go to 76, all right?
Yes, sir.
We can't tell
Okay.
which one.
Which one should I say?
Yeah, would you please? Because I'll forget.
I will.
Jaws, will you stop it?